rear wheel and the pedal of a bicycle are connected by a chain that passes around the two cogs. The small cog has a radius of 0.038 meter and is fixed to the rear wheel so that it rotates with it. The larger cog has a radius of 0.15 and is fixed to the pedal so it rotates with it. The rear wheel has a radius of 0.46 meter. The bicycle is being pedaled so that it moves in a straight line at a constant speed of 17 meters second minus 1. Calculate the angular speed of the rear wheel. So omega rear wheel is equal to V rear wheel divided by R rear wheel. Okay, and V rear wheel is equal to V bicycle. So omega rear wheel equals 17 divided by radius of rear wheel, which is 0.46. So the result will be 37 rad minus 1. Calculate the period of rotation of a small cog. So as a small cog is fixed to rear wheel, omega small cog is equal to omega rear wheel. Okay, and omega is equal to 2 pi over t, so t equal 2 pi over omega. So it is 2 pi over omega rear wheel that we have just calculated, 37. The answer will be 0.17 seconds. Shows that distance moved by point x on chain during one full revolution of small cog is 0.24. So during one full revolution of small cog, distance moved by a point on the small cog, okay, will certainly be the circumference of small cog, which is 2 by r small cog. So it is 2 by times 0.038, which gives 0.24 meters certainly. Use information in BIII to determine the angle through which larger cog rotates during one full revolution of small cog. So distance moved by large cog, okay, let us name it as just S large, is the same as distance moved by S small cog. A point on small cog will move an arc that equal in length to a point in large cog because both cogs are connected by chain. Okay? And by the way, it is also equal to the distance moved by some point, say x, on the chain. Okay? During one full revolution of a small cog, we found the distance to be 0.24, and we know the relation that S equals theta r or r theta. So we can find theta angular displacement by large cube as a division of S large over R large, which is the division of 0.24 divided by radius of large cube, which is 0.15. Okay, so the result would be 1.6 rad. The chain of the bicycle is moved onto smaller cube fixed to the rear wheel. The speed of the bicycle doesn't change. Explain without calculation the effect of this change on angular speed of the pedals. So, as speed doesn't change of the bicycle, the speed of rear wheel also doesn't change. And omega rear wheel, okay, doesn't change. It is the same. So omega small cog1 would be equal to omega small cog2. So as the chain is moved from the first small cog, okay, to the second smaller small cog, omega for both small cog1 and small cog2 will be equal. Okay, and we have S small cog equal to S large cog, whether it is with small cog1 or with small cog2. If we replace S by R theta, so it is RS1 theta S1 equals RL, and I'm not going to make a subscript 1 or 2 because large cog hasn't changed, and theta large, this will be large cog1 because after the change to small cog2, theta large cog2 will be different from that of 1. So RS2 theta S2 equals RL theta L2. Okay. To find the change on angular speed of pedal, which is angular speed of large cog, we have to find the relation between theta large cog2 and theta large cog1. So we can write it like this. here okay. For certain time, same time before a change, I mean during S1 or during S2, as omega S1 equal omega S2, theta S1 will equal theta S2. So when we do a ratio between theta L2 over theta L1, we can remove theta S1 and theta S2 to have, and also RL with RL, to have only RS2 over RS1. And as RS2 less than RS1, theta L2 will be less than theta L1. And again, for same time, this means that omega L2 will be less than omega L1, so omega larger code decreases.